So we have already finished with the theory of limits. We have done the various strategies of solving the problems, and lots of good examples we have taken, but content wise examples are being taken. Now we are discussing miscellaneous problems on the entire theory, which is actually belonging to exercise 3. In fact, I must say that we are discussing all the problems of exercise 3. Exercise 3 containing 25 problems. I will write most of the problems on board and then we'll discuss it. So is your first question written over here is, if f of x is equal to x upon sin x for x greater than 0 and 2 minus x for x less than 0, in fact equal to 0. You have been given gx is equal to x plus 3 for x less than 1 and x square minus 2x minus 2 for x between 1 and 2 and x minus 5 for x greater than or equal to. Equality is not here, equality is given over here, and he is asking left hand limit and right hand limit of LHL and RHL of g of fx, g of fx at x equal to 0. Generally, we try to solve this problem finding g of fx, but that might not be a correct idea of solving this problem here, because finding g of fx for all values of x is correct. That will be applicable here also, but only for x equal to 0 we should not find that much. So let us discuss the left hand limit and right hand limit. I am discussing g of f of 0 plus, means I am discussing the right hand limit. Here g of f of 0 plus is g of f of 0 plus, notation wise. Now I want to know what is f of 0 plus, means I have to discuss the part over here. As you know, sin x upon x for x tending to 0, or I must say the graph of sin x by x around x equal to 0 is less than 1. Sin x by x is less than 1 around x equal to 0. But here you have x upon sin x. So what will be this? It will be
1.
more than 1.
But we take it as 1 only, no? Because you just standard limit ki
We are discussing around x equal to 0, not at x equal to 0.
Okay, fine.
Around x equal to 0, it will be above 1.
Right.
So it will be 1 plus, I guess.
Okay.
Sin x upon x is 1 minus. I am talking about graph, I am not talking about limit. I am talking about graph. X upon sin x will be just above 1.
Okay.
It will be inching towards 1, but from the above side.
Yes, sir.
So f of 0 plus will be g of 1 plus or 1 minus?
1 plus.
1 plus. So I am writing it 1 plus. Now I have to calculate g of 1 plus from this place. The value for x less than 1, value for 1 or more than 1. I'll get g of 1 plus from this place.
Yes, sir.
When I say I'm talking about 1 plus, means I'm talking about limit extending to limit extending to 1 plus g of x. Means I'm looking at the right hand limit of gx around x equal to 1. And what is it over here? Look, this function is continuous at x equal to 1. I'm not interested in 1 minus. But for 1 plus and for 1, this function is a polynomial which is always continuous. So I can write 1 directly over here. What do we get? We'll get g of x. I'll put 1 over here. This is 1 square minus 2 minus 2. This is coming out to be minus 3. This is coming out to be minus 3. Now just tell me x upon sine x. Now we have already discussed this RHL. If I talk about LHL, left hand limit, means I'm talking about g of f of 0 minus. There are two ways to think about it. Number one, we have already discussed that this function around x equal to 0 will be below 1.
Yes.
But this function will be above 1. Sin x by x is below 1. And this function is an even function. So for 0 plus and 0 minus, both, it is sin x by x is below 1 and x by sin x is above 1. So again, this limit is coming out to be g of
f of 0 minus will be 2 minus x, right? Because the function should be, we should take 2 minus x for less than 0.
For 0 minus you have to discuss here.
Ah.
You're right.
Yes.
So we should not discuss it. Good comment. For writing 0 minus, you have to choose another function. For 0 minus, what about this? If you write 0 minus over here, what do we get over here? 0 minus if you put here, then this is coming out to be 2.
2 plus.
Approaching towards 2. And it will be 2 plus.
2 plus. Yeah.
So this is coming out to be g of 2 plus. What is g of 2 plus? Where from you will find it? Here.
Yes, sir.
It is again coming out to be minus 3. Approaching towards minus 3 you can say. So this is coming out to be minus 3. So LHL is equal to RHL. We can say here limit x tending to 3, not 3, 0, g of fx exist. Are you clear?
Yes, sir.
Right. So can we move for our second question?
Yes, sir.
This is first question. Okay, you don't have to write it, okay? Question should be discussed on conceptual ground along with the theory what we have done in class. Second question is asking if p subscript n is equal to a raised to power pn minus 1 minus 1 for all n belongs to
Sir, minus 1 नीचे आएगा ना?
it's minus 1 here, okay. And n is equal to 2, 3, 4 means natural number is given. One more information is given, that is a raised to power x minus 1. It's obvious that a should be positive, but still it is given. A belongs to R positive. And it's asking solve limit x tending to 0 Pn upon x. Now just look at this and this. How can you make some sense related to P1 with this one? Can you please tell me, when you are finding Pn upon x, that means you are exactly writing the step x tending to 0 a raised to power p n minus 1 divided by x. If I can prove that this part which I am putting a circle is approaching towards 0, then I am sure that I am going to multiply and then divide it by p n minus 1 so that this becomes
Standard limit.
standard limit. Now I have to look at p n minus 1. What is p n minus 1? suppose I am able to prove that Pn minus 1 is approaching towards 0. Then my problem will be for Pn minus 2. Because again I have to solve that Pn minus 2 result.
Yes.
So let us discuss Pn minus 1, Pn minus 2, what are these actually? You have been given P1 is equal to a raised to power x minus 1, and what is it for x tending to 0, I want to know. Can you please tell me what is
So
it?
it will be tending towards 0.
It will be tending towards 0. Now what is P2? P2 will be equal to, according to this given result, P2 will be a raised to power P1
Yes.
minus 1,
Which is again tending towards 0.
which is again tending towards 0. Very good. Similarly, I can write P3 is equal to a raised to power P2 minus 1,
Yes, sir.
P2 approaching towards 0,
A की power 0.
then it is again approaching towards 0, and so on.
Yes, sir.
It becomes a recurring relation actually. So you can prove Pn is also approaching towards 0.
Yes, sir.
Now our first question was the same actually. My purpose of solving limit is when I get indeterminate form. So first of all, if I am not being able to prove that Pn is approaching towards 0 and it is a non-zero finite quantity, then limit will not exist because the denominator is 0. Here we have proven that Pn is also approaching towards 0 for x tending to 0.
Yes.
So let us start solving this question now. A raised to power Pn minus 1 divided by Pn minus 1 multiplying by Pn minus 1 by x. Now what is it?
So this quantity becomes 1.
This
No,
one, no.
LNA.
This is becoming ln.
Yeah.
And now what is Pn minus 1? Can you please tell me? A raised to power
N minus.
Pn minus
P of
1.
N minus 2.
Pn minus 1.
So
P
P of
minus
N minus
2.
2.
Minus 1 divided by x. Again what will you do?
Again the same thing. So
What
we
will you do? Just let me know what will you do.
divide and multiply by P of N minus 2.
Yes. Very good. Pn minus 2 upon Pn minus 2. So this part becomes ln once again.
Yeah.
And this is left. So I will write ln whole square into Pn minus 2 upon x. Now can you conclude what are we going to get in the end?
So
This ln will be repeated how many times?
N times.
N times. What will be the last n times or n minus 1 times?
I guess N minus 1 shall have to do.
What will be the last result? Just tell me. If I keep on writing this, then when I am writing Pn minus 2 here, I am getting power 2 over here. When I write Pn minus 3 here,
We'll
I will get ln a raised to power 3.
3.
So in the last result, I will write Pn minus n minus 1.
So
Then I will have power
N minus 1.
ln a raised to power n minus 1. ln a raised to power n minus 1. And what do I get here?
P of 1.
P of 1 divided by x.
Yes.
Now what is P of 1? We have already written here. A raised to power x minus 1 divided by x. Which will give you again ln a.
LNA. Right.
So this is coming out to be what?
LNA की power N.
ln a raised to power n. Have you understood this? Is there any problem? Okay. So our first goal is to prove that Pn is approaching towards 0. Then only there is some sense of solving limit. Otherwise, we don't need to solve limit.
Other determinant.
Yes. Understood this?
Yes, sir.
Fine. So let us move towards third question. We are taking hardly 3 to 4 minutes to solve a question. We are taking all these questions as an example actually. You have been given fraction, this is not fractional part, this is representing some sequence actually. Sequence an, sequence bn. This is question number 3 we are solving, and sequence cn. There are 3 sequences, and the results related to the 3 sequences given to you, an plus bn plus cn is equal to 2n plus 1, and an bn plus bn cn plus an cn is given to you 2n minus 1, And one more, third result is given to you. AN, BN, CN means product of these three is coming out to be -1. One interesting result given to you that AN is less than BN is less than CN means N is the smallest one. And is asking solve limit n approaching towards infinity n times AN. This question is a mixed problem of theory of equations and limits. Just look at these three results. What does it imply?
The summation of roots and
Sum
then
of roots
taken 2 at a time and then taken 3 times.
taken 3 at a time. Very good.
So,
So can I form an equation whose roots are A and B and C?
yes, cubic equation.
What will be that equation? Can you please tell me?
So x cube
X cube
minus
minus
2n plus 1 into x
2n
square
plus 1 into x square.
plus 2n
plus-
minus 1 into x
Very good.
and then plus 1.
Plus 1 equal to 0. Excellent. Trivially, can we say x equal to 1 is the root of this equation? Just
Yes,
look
sir.
at this.
Yes, sir. 1.
Yes. When putting x equal to 1 here, you get 2n minus 1, where 1 is 1, 1 and 1 gets cancelled, right? Plus 2n over here left,
And right.
and minus 2n over here left. This is cancelled. Now extra 1 with negative sign left over here,
But then that gets cancelled.
and that cancel with this one. That means x is equal to 1 is the root.
Is a root. Yes.
Then what will I do?
Uh,
Now a
factorize
cubic
it.
equation, we will factorize it. Can I write the factor directly?
Yeah, we
Because you will divide it, so you will get factors. So you are getting factors x minus 1, and the remaining factor I will write.
x square and then the right.
We will divide it like this. X minus 1. I am putting it over here, okay? And I will treat this factor. In fact, I must do one thing. I will erase this, and I am dividing it religiously with x minus 1. Let's see what happens. What do we get here? X square first of all. What do we get?
So x cube
X cube minus
x square.
x square. What is left? X cube is over. This is
2n minus 2.
this is plus
So 2n x square.
2n x square. Minus or plus? Minus 2n
Minus
x
2n
square.
x square.
Right? And plus 2nx minus x plus 1. Okay?
Yes, sir.
Now what to do? X square minus
So
2n.
minus 2n.
What do we get here? Minus 2nx square. And what is left?
Plus 2n.
Plus 2n. In fact, I must multiply it by
X square.
2nx.
2nx. Right. So,
So what do we get here? Minus 2nx.
sir, plus 2n.
Plus 2nx, I'm sorry. Plus 2nx. And that's it. So this is plus, this is minus. Get over. What is left? Minus x plus 1. I guess the third term factorization is over.
Yes.
What should I write here? Can you please tell
Plus
me?
1.
Plus 1. No, it's
Minus
minus
1.
1.
Minus 1. Yeah.
So what do we get here? Minus x plus 1. This is over. So the factors are x minus 1, x square minus 2nx minus 1 equal to 0. I will get the factors as x is equal to 1 and x is equal to minus b plus minus under root b square minus 4ac divided by 2a. So what do we get here? 2n plus minus under root b
4n
square means
square minus
4n
1.
square
Plus 4.
plus 4 divided by 2. I guess 2 cancel out through. So I'll get roots. This, let us consider this is x1. I'll get x2 as
n plus minus n square plus 1 root over of n square.
n plus under root n square plus 4 and
Sir, n square plus 1 you have.
n square plus 1, you are right. And what about x3? n minus under root n square plus 1.
Yes.
Okay. Now, what do you want to do exactly? You want to solve n tending to infinity n times a. Now you do not know what is a, or we are getting 3 roots over here. Exactly 3 roots over here. We are having this equation of 3 roots, a n, b n, c n. Now which value is representing a n, which one is b n, which one is c n? For that you have been given
an less than bn.
This is the fourth relation given to you.
Yes.
An less than bn less than cn. So which will be an will be the least one. Okay. Now we are not confused with this one. This should be cn. Because for n approaching towards infinity, it is anyways more than 1. Approaching towards infinity. So either 1 is an,
Or so third
if
one.
1 is an, then the answer will be infinity. Okay? If I consider this as an, then the answer is infinity. If this is an, then answer will be different. Now let us consider which one is bigger.
Or otherwise we can also say na, ki since the product is negative and the smallest number should be there, so an cannot be 1.
N cannot be 1. Very good. Very smart. One more thing, if you calculate it, this is always less than n.
That is also there.
I mean, this is always negative. This can't be positive
Right.
for any value of n. So this is the smallest one anyways.
Yes.
Right? So your an is actually x3. x3 is an. x3 is an. So limit n approaching towards infinity, n times an means n times n minus under root n square plus 1. Okay?
Yes.
What do you get finally? Rationalizing it, what do we get? N square
N square minus n minus 1.
minus n square minus 1 whole divided by n plus under root n square plus 1. This is over, minus 1 left. Now n carry out common, n cancel. Can you please tell me the direct answer over here?
So
It will be 1 upon 1 left from this place and 1 left in under root.
yeah. So 1 by 2.
So the answer is 1 by 2. Can you please verify the answer?
So from that.
Yeah.
So it's minus 1 by 2.
Minus 1 by 2. Actually we are missing minus 1. Just look, we are getting minus 1 in the numerator. This is a careless mistake.
Yes, sir.
Be careful. Okay, understood?
Yes, sir.
Okay. Solution will be uploaded, so you don't need to write the solution. Sometimes when you feel that calculation is needed, then only you write the calculation part. Okay? What is the next problem? This is a simple problem actually. You just need to find out an. We have done it in sequence and series.
Yes.
We have been given. I will leave this problem for the students. Do you want me to solve it?
Yes, sir.
Okay.
So, but देखिए आप लिमिट में क्या है? I think it is solvable. हो जाएगा शायद.
Actually, you know the sum of these terms.
The results पता ही है सबके.
All the results you know, so you can find the summation, right? So I will not take it as an example in this particular exercise. I am talking about question number 5 now. At the endpoints A and B of a fixed line segment L, let us consider this is the line segment. These are the fixed points. The lines are drawn meeting C and making angle theta and 2 theta respectively, means this is theta and this is 2 theta. It should be properly made actually, but we will write this angle. This is theta and this is 2 theta, and they are meeting in C. It is given with the given line segment. Let D be the foot of the perpendicular or foot of the altitude CD. This point is given to you D, and this length is given to you L. Okay.
Yes, sir.
Length of the
So
altitude.
AD is L, not AB.
You have been given AB is equal to L. At the end points of A and B, the fixed line segment of length L means AB is L. In the beginning of the question.
Right. X is AD, sir.
And this is X. AD is X or CD is
AD,
X?
AD.
The D is the foot of the altitude CD, and let X represents AD. Okay, I'm sorry. This is X. So this is L minus X. He's asking the question, find the value of x as theta tends to 0. Find the value of x as theta tends to 0. Theta from this place you can take, or from this place you can take. This will be L minus x. Is it okay?
Yes, sir.
Now, this is a right angle triangle. And you know this is x. And let it be y. Okay? Now, what would be tan theta? Y by x.
Yes, sir.
Am I right?
Yes, sir.
And what would be tan 2 theta?
Y by L minus x.
Y by L minus x. Okay?
Yes, sir.
And tan 2 theta, I can write it 2 tan theta upon 1 plus
1 plus
tan square theta. 1 minus tan square theta. 1 minus tan square theta. Okay? Can we eliminate y from this place?
Sir, tan.
I will write y is equal to x tan theta.
Yes, sir.
So I will write it here. So I will get x tan theta divided by L minus x is equal to 2 tan theta divided by 1 minus tan square theta.
Yes, sir.
Right? Now, what is your purpose? What is your goal? What do you want to solve? When theta approaching towards 0,
Find x.
x approaching towards what? When theta approaching towards 0, what happens? This tan theta is over, because theta is not exact 0.
We can cancel
Approaching
that.
towards 0, so you can cancel it.
Yes, sir.
Okay? So can we get a relation in theta, in fact tan theta and x?
Yes, sir.
Right? When tan theta is approaching towards 0, when theta is approaching towards 0 means tan theta is approaching towards 0.
Yes, sir.
What exactly are you finding when theta approaching towards 0, x approaching towards what, right? Means you have to find out the value of x over here
Yes, sir.
when this is approaching towards 0.
So we can substitute it as 0 and then.
Let us see. X upon L minus x is equal to 2,
Yes, sir.
isn't it? So you are getting x is equal to 2L minus 2x.
X is equal to 2L by 3.
So this is x is equal to
2L by 3.
12 by 3. Can you please verify the answer?
2L by 3.
Right?
Yes, sir.
Okay. Question number 6. Or I must say example number 6. He is asking to solve a limit x approaching towards infinity cos of 2 pi. I guess we have done this question in class. X upon 1 plus x
Yes, sir. That's me here.
raised to power a whole raised to power x square. We must write a belongs to q here instead of r.
Yes, sir.
First of all, we should identify what kind of indeterminate form is there.
1 raised to infinity.
1 raised to power infinity. How do you come to know about it?
So x plus 1 by x is tending towards 1.
1. This is approaching towards 1. 1 raised to power tends to 1 raised to power some rational number.
Is
Will be 1. So cos of 2 pi approaching towards, this is approaching value. So this is approaching towards
Towards
1 raised to power infinity. Excellent. This is x square or x? This is x
X
square.
square.
So 1 raised to power infinity, how do we solve?
So g of x into
We will,
exponent form.
the answer is e to the power l here. And what is l? L is equal to
x square.
fx minus 1 into gx. You are right. Cos of 2 pi times x upon 1 plus x to the power a minus 1 into x square. Right?
Yes, sir.
See, whenever I solve a problem and I get limit x approaching towards infinity, generally I am tempted to write x is equal to 1 by y. Right? It's really not necessary all the time, but in my point of view, you should do it.
Yes, sir.
When x is approaching towards infinity and you are writing x equal to 1 upon y, you should always write y tends to 0 plus.
Yes, sir.
What if I write x tending to minus infinity?
So 0 minus.
It will be 0 minus. So let us write and solve it.
Yes, sir.
Cos of 2 pi times, if I write x equal to 1 upon y, the expression is changed. This will be cancelled.
Yes, sir.
and we get 1 upon 1 plus y raised to power a minus 1 into y square in denominator.
Yes, sir.
Right? I will take it over here. First of all, just let me know. Do you remember this result? We have done it in class. 1 minus cos function divided by function for x tending to its function square,
Function square.
x tending to a.
F of
If function is approaching towards 0, what is the result?
So 1 by 2.
It's half. But function should tends to 0 for given limit. Here y is approaching towards 0 plus. Now for y approaching towards 0 plus, is it approaching towards 0? Is this part? It is not.
So we subtract.
So what to do?
Subtract it by 2 pi.
Very good. Subtracting by 2 pi. I've got excellent student with me. So what are we going to get here? I will carry out minus common first. Out of these two, minus.
Okay.
And I am writing 1 minus cos of 2 pi minus 2 pi times 1 plus y raised to power minus a.
Yes, sir.
This is the main angle now. Divided by y square. Are you clear?
Yes, sir.
I must write limit y is approaching towards 0. Are you clear?
Yes, sir.
Now can you suggest me what to do?
Sir, multiply and divide by 2 pi minus that function
This part.
square.
Square. So I will be writing this part here and the same part here. This is same part. And this, what would I write this part?
1 by 2.
1 by 2. And the rest of the part I have to solve.
Yes.
Let us see. Don't neglect the negative sign. 2 pi is out. What is left? 1 minus
1 minus
1 plus y raised to power minus a whole divided by
y square.
y square, and this negative sign is here, and we get limit y tending to 0. So finally what are you going to get? Minus 2 pi. I will expand it. A belongs to the set of rational numbers. I can expand it.
By
1 minus binomial expansion. Can you please tell me the
1 minus
steps?
a1.
1 minus a1. One more step we need because this one will get cancelled.
And
Minus
minus a into a plus 1 into y square by 2.
Are we doing
Plus,
this step right?
plus a into a plus 1.
Plus a into
A plus 1
e plus 1
y square
y square
by 2.
y factorial 2.
That becomes 2 only.
Right? Don't forget, this is numerator. You have this part you are writing. Okay? Is it clear till this step?
Yes.
Minus up to so on, whatever. Okay? And we have to take the square of this. Don't forget this.
Okay.
Square of this.
तो सर मैं y square का टर्म भी लिखने की फिर
जरूरत नहीं था.
हाँ.
Actually we don't need. Divided by, and the minus 2 pi में this minus is outside.
Yes, sir.
This minus is outside. Okay? Square of this. I must write here only square. Okay? So this one is over. Y square. Can you write the direct answer over here?
Sir,
Because this term is
2
not
pi.
needed. Anyways, this is coming out to be 0.
Yeah.
So what is left?
2 pi a.
2 pi a whole square
हाँ, the whole square.
with negative sign.
Yes.
So what is left? Minus 2 pi square a square. But this is
four.
not the final answer.
4 ना?
Yeah, this is 4. I'm sorry. So what is the final answer? This is not the final answer. This is L actually.
अच्छा, e की power है.
So the final answer is e to the power L. That is e to the power minus 2 pi square a square. Basically, all the questions are similar. You just have to identify how to go through it. What is the approach?
Yes.
Isn't it? Here just you needed to subtract, and you only told me to subtract it. Okay? We have done this kind of questions in
Yes,
class.
yes.
Right. Let us move towards the next question, question number 7. When did we start? How much time we have passed? Can you please tell me, looking at that? How much time? Can you tell me?
Sir, behind.
Around about
20 minutes, 25 minutes, I guess.
half an hour, not more than that.
I don't think so.
Okay. Half an hour, 6 questions. Let us see how many questions we can take an example. Limit extending to 0. Identify the indeterminate form and then only start solving it.
So इसमें भी वापस 1 की power infinity.
Raised to power 1 by x. See, our challenge is not to use series expansion and L'Hopital. That's it.
So why not series expansion?
No, actually that is fine. Using series expansion and L'Hopital is fine while appearing for the exam.
I don't use, but
No, that is right. Attempting the question using series expansion is very much correct. But to encourage yourself involving in the methods, and when you solve using some different methods, you actually feel good to solve a problem related to it. It's becoming 1 to the power infinity.
Yes, sir.
So, can you suggest some start?
So
E
same
to the
sir.
power n.
E power
I will
n
write directly. What is n? N is equal to x minus 1 plus cos x
minus of 1
minus x
minus x
divided by x
into 1 by x.
into 1 by x, and the limit is x is approaching towards 0. This x is over,
ये तो directly आ गया minus
and
1 by
this
x.
is directly. I mean, this is very easy problem. I guess this is coming out to be cos x minus 1 divided by x square
minus 1 by 2.
minus half. So e to the power minus half should be the answer. Can you please verify the answer?
Yes, sir.
Okay. Can you please tell me how to solve question number 8? Seventh, this is number 7 we have done, right?
Yes, sir.
How to approach question number 8? Question number 8 is similar to this question. I will not solve this question. In fact, I will give you a hint. 3 to the power 1 by n plus 5 to the power 1 by n minus 1 raised to power n for limit n approaching towards infinity. This is a classroom example. Okay? You should try this. This question and the given question is same. Let us try. Okay. Still, question number 8 we are trying. For a1 raised to power 1 by x up to so on, in the last an raised to power 1 by x whole divided by n
Okay, हाँ ये वापस वही 1 to the power infinity form.
raised to power nx, and limit is what? X is approaching towards
Infinity.
infinity. So everything 1. a1 raised to power 0, a2 raised to power 0,
Yes, sir.
n by n is 1 to the power infinity.
Yes, sir.
So what is the approach? You will tell me the approach and I will write.
Sir, same as we were doing. E की
This
power
is
n.
e to the power n, and what is n?
L is equal to nx.
a1 raised to power 1 by x. Can I write it directly x equal to 1 upon y in the solution, and I can write the step? Just let me know what is L in that case.
Sir, a1 raised to y. plus
a1 raised
a2
to
raised
power y up to so on
till
a
n
raised to power y
upon
divided
n.
by n minus 1
n minus 1 into n by y.
n by y. Excellent. Now I'll put it over here.
Yes, sir.
a1 raised to power y up to n raised to power y divided by minus n divided by n
It gets cancelled out by
into n by y. N gets cancelled, and the limit is, what is the limit?
y tending to 0.
Y tending to 0. See, in this step you can differentiate and you can get the answer in a step, but still you can find it by the other method also. That is also simple. This n is a natural number. It is given in the question. Actually, I have not written here. Right? Can I distribute this n times minus 1 with each a1, a2
Yes.
and so on? What do I get?
So
a1 raised to power y minus 1
plus a2 की power y minus 1 and so on till an की power y minus 1. All of them divided by y.
a n raised to power y minus 1, and everyone is divided by.
Y.
So what is this?
ln a1.
ln a1.
ln a2.
What about the last one? ln
a.
an.
a.
Finally, what are you getting? I am writing here ln a1, a2 up to
a.
an. But this is not the answer. This
E
is
की
l.
power. हाँ.
If I write the answer e to the power l, then what do I get? e
A1
raised to
into,
power ln of this product,
which is A1 into.
which is actually a1, a2 up to an. I guess you have understood this.
Yes, sir.
In fact, you have solved it. Right? Got it?
Yes, sir.
Okay, fine. Look at the next question. What is he asking? It's a good question. This is question number 9. Given f of x is equal to sine inverse 1 minus fractional part of x, cos inverse 1 minus fractional part of x divided by root 2 times fractional part of x. Here fractional part of x is the function whose value is lying between 0 and 1, close 0 to open 1. Have we done it in class? Fractional part of x we have done in class.
This question?
Not the question exactly, but fractional part of x we know the properties.
Yes, sir.
Okay. Now he's asking solve the limit extending to 0 plus and 0 minus. I mean he's asking what is limit extending to 0 plus fx and limit extending to 0 minus fx. I will suggest you one thing here. Whenever you see fractional part of x and you are stuck at a problem, you should always resolve it into x and box x,
Yes, sir.
in case of limits at least. So I will write fractional part of x is equal to x minus box x. Now for limit extending to 0 plus, fractional part of x becomes x only, because box of 0 plus is exact 0,
Yes, sir.
and limit extending to 0 minus, fractional part of x is what? Can you tell me?
So,
0 minus.
yes, sir.
If you put 0 minus here, this is x.
This is X.
You cannot write limit over here. This is exact limit. What do you get
So,
if you write 0 minus here?
minus of boxes.
Minus 1. Minus box of 0 minus is minus 1. So
Minus
this becomes what? Can you please tell me? X
minus
plus 1.
Acha, minus we have.
Is it okay?
Yes, sir.
Now I'll use this particular condition in the question, and the question will become an easier question. Now this becomes very tedious and difficult question. The question is now limit extending to 0 plus I am calculating, I am writing sine inverse of, for 0 plus I have already written fractional part of x is equal to x.
Yes, sir.
So I'll write it sine inverse of 1 minus x cos inverse of 1 minus x divided by under root 2x into 1 minus x. Now can you please tell me which part in this function is responsible for making indeterminate form?
So,
For extending to 0 plus,
so one cos inverse of
yes,
and
this is making 0,
the by root 2
and this one.
to x.
So we are interested in this part and this part, that's it.
Yes, sir.
This will obviously be coming out to be sine inverse 1, which is pi by 2, and this is 1. Can I write it pi by 2 directly?
Huh.
Okay, I will write it pi by 2. And the remaining question is cos inverse 1 minus x divided by root 2x. Now we have to work on this particular question
Yes, sir.
for limit extending to 0 plus. Number 1, fractional part of x should have a breakup like this. And then if the inverse problem is there, you should always try to avoid the inverse problem.
Yes, sir.
Means change the inverse into trigonometric functions. Means you write 1 minus x equal to cos theta. When x is tending towards 0, cos theta is tending towards 1. It cannot go beyond 1 obviously.
Yes.
So it will be 1 minus anyways. We can take theta 0 plus or 0 minus, makes no difference because cos theta is
Symmetric.
even function, right? So I will write theta tends to 0 plus here.
Yes.
Okay. So what do we get? Limit theta tends to 0. In
Theta.
fact 0 plus or 0 minus makes no difference here.
Theta.
Pi by 2. Cos inverse of cos theta it becomes 1 minus x, right? This becomes theta
Theta.
divided by
root of
root 2
1 minus cos theta.
and under root 1 minus cos theta. That is 2 sin square theta by 2. What do we get? Pi by 2 root 2 into root 2 mod sin theta by 2. Theta tends to 0 plus. Here see, here theta tends to 0 minus. You cannot take, in this case mod will be different. Since you are solving one-sided limit, take one-sided limit. Either 0 plus you can take or you can take 0 minus. One out of the two. So when taking 0 plus, what do you get over here? Sin theta by 2 is equal to mod sin theta by 2 is equal to sin theta by 2.
Sin theta by 2.
So and theta is there in the numerator. 2 is over here. Look at this. This theta with 2. This will become 1.
Yeah.
What is left? Pi by 2.
Pi by 2.
Only pi by 2. Just verify if we have not left anything. It's going proper. Right? Similarly, you can solve for limit extending to 0 minus. What is limit extending to 0 minus? We would like to skip some steps here. When limit extending to 0 minus, fractional part of x becomes x plus 1.
Which is
So this becomes what?
sin x. Sin inverse of x
Sin inverse of x
into cos inverse of x
into cos inverse of x. Very good.
upon root 2x into x.
Root 2x. No, it's not root 2x. Fractional
into
part of
x
x
plus
is x plus 1.
X plus 1. Sorry.
What else?
And x.
And x. Now which part is responsible for making indeterminate form? Obviously this is not. This is not.
Sin
This
inverse
part
of
is
x.
responsible.
this
And
part,
we know this value is 1.
that one is
So what is left? Cos inverse 0 is
pi
pi by 2 and root 2 is over here.
Yes, sir.
So what is left? Pi by
2.
2.
That is not equal to r.
So limit does not exist. Have you understood this?
Yes, sir.
So we have finished with question number 9 as an example. Can you identify what to do with question number 10? I guess this is a classroom example, but we haven't solved it. I had given it for homework and no one could answer it on the second day also, except few students in few branches. I will write the complete question. You try to identify how to go through it. Limit extending to a. 1 by a square minus x square whole square. A square plus x square upon ax minus 2 sine a pi by 2 sine of pi x by 2. It seems a dirty question where it is given that a is odd integer. A is odd. Let us write only odd natural number, because for negative numbers also it will behave the same.
Yes, sir.
We have to concentrate odd number only. Just think about it. First of all, think about the indeterminate form you are getting.
0 by 0.
How come 0 by 0?
Sir.
If I write 0 over here, I'll get 0. And what about the rest of the part? So this becomes a finite quantity.
That becomes
X becomes x tending to a means this will become 1. 2a square by a square. Yes, this becomes 2.
Yeah.
This is odd by 2. This is odd by yeah, that's right. 0 by 0 form you are getting. So how to solve this 0 by 0 form? I guess here we should substitute something.
Okay.
I mean, as far as this part is concerned, you should not be bothered much about it, because we can verify it in the end.
Yes, sir.
If you write a is equal to 1, it will become 1. But if you write a is equal to 3, it will become minus 1.
Yeah.
So the only distraction over here is the values of a kind of 1 giving different answer, kind of 3 giving different answer. So finally when we are solving it, we have to consider two cases.
Okay.
Right? So let us write, first of all, let us write x equal to a plus h. What do you get in the denominator here? If I write a plus h here, then can you make the factors separately? A minus h whole square and a plus h whole square, isn't it?
Yes, sir.
So this is cancelled out. What is left? H square into
2a plus h.
2a plus h whole square. What is left inside? I will write here also. I will write directly a plus h whole square and 2a square plus 2ah plus h square. Am I right?
Yes, sir.
Divided by a times a plus h means a square plus ah
Yes, sir.
minus 2 sine a pi by 2. What else do we have to write here?
Into sine
This also I will write it separately. Sine of
pi.
pi by 2 a plus h.
Yes, sir.
So this will become sine of a pi by 2 plus a pi h by 2.
Pi h by 2.
So I will write it over here only into sine a pi by 2 plus pi h by 2. Right? Try to identify the pattern over here. Pattern is important. See, whenever you are solving any problem, in each step what you write, you should always identify, have I reached at some conclusion?
Yes, sir.
I mean, it's very important. Sometimes you go very lengthy and you do not know whether you have completed the question in third step, fourth step previously. So, try to identify the pattern in each step. Just look at the pattern here. You are having 2a square here. If you take the LCM over here, a square, don't forget this h square over here for extending to 0. Right?
Yes, sir.
If I carry this h square along, what do I get? H square multiplied by this, and it will, no, h square will be divided by this also, no? So we are interested in this factor to take over here.
Okay.
And then we will divide the entire expression by h square. Now I'll get 2a square sine of blah blah here, and I get 2a square over here also. So I'll carry out 2a square common.
Alright.
So what do I get? Can you please tell me? 2a square is
2a
common.
square into 1
1 left from this place
1
minus
sine of
sine of
a
a pi by 2 into
sine of a pi
sine
plus
of
pi
a
h
pi
by
by 2 plus
pi h by 2.
pi h by 2, right? And this whole part is divided by, I must write one bracket over here, divided by what? H square. See, I am not interested in the other factor, 1 upon 2a plus h whole square. Can you please tell me why I am not interested in the other factor to take in?
Because वो indeterminate form में
This will not participate in indeterminate form, right? So that is fine. And what else is left now? AH I will multiply here, so I will get 2AH. Just look at the pattern. 2AH you are getting here,
Yes, sir.
2AH you are getting from this
So we
place.
get the same thing.
So you will get the same pattern over here. So plus 2AH, I will write the same,
D square
plus
के
2AH
बाकी
is common.
We can write it with a square only, ना?
That is fine. I mean 2a square, I can write it like this, 2a square plus 2AH. And the same factor I will get,
Yes.
right? That is nice. Plus, what else is left?
Plus
Some-
h square.
Something left?
Only h square is left.
Only h square left. H square, yes, this h square left. So plus h square I will write here. And this divided by h square. Am I right?
Yes, sir.
Now please calculate this fast. Calculate in your notebook. Done कर दो उसको.
So sin c cos d क्या होता है? Sin c sin d क्या होता है?
No, you don't have to use sin C, sin D. See, you are very much free from this particular step. Okay. Now you are bothering this step. What to do? Now we have not used this a is odd integer. If I take a is equal to 1, what do we get? A is equal to 1. Sin pi by 2 is 1. A is equal to 1 here means sin pi by 2 plus pi h by 2,
Which is that.
which is cos pi h by 2.
हाँ.
So if I take the condition a is equal to 1, one type of element,
हाँ.
1 then 5 then so much, right?
Yeah.
If I put a equal to 1, what do I get? 1 or 5 or 9, etc. Okay, then what do we get? 1 upon 2a plus h whole square. What is left inside? 2a square plus 2ah. What is left inside? 1 minus cos pi h by 2.
Okay.
Because this will become 1 anyways.
Huh.
And this will be a pi by 2 means either pi by 2 plus theta or 5 pi by 2 plus theta or 9 pi by 2 plus theta. In all the cases this will become cos pi h by 2. So I am writing here.
Yeah.
Now divided by what? X square and plus 1. You can put the limit and in the end also.
Huh.
Okay. Now I guess the question is over now.
Huh, that is standard limit.
Because this is a standard limit. What is needed over here in denominator?
Pi by
Can you please tell me?
Pi by the whole
square. Yeah, pi by 2 whole square I need.
Huh.
So I will write this plus 1 here. I will write pi square by 4 here and pi square by 4 here. Right?
Yes.
Now I am putting the limit on the whole. Okay. In fact, here also I should have put in the limit directly. But that is fine. What is this?
1 by 2.
1 by 2. For this h tending to 0 is over.
Huh.
So what is left? 2a square into 1 by 2 and pi square also.
Huh.
2 and this is over. So what is left? What is cancelled? Pi square by this 2 is over with this 2.
Huh. So pi square by 2.
So a square pi square by 4
Huh.
plus 1.
Plus 1.
So I'll write this final answer. 1 upon 4a square from this place.
Yeah.
What is left inside?
A square pi square
A square pi square
by 4 plus
pi 4 plus
1.
right. If you wish, you can multiply this to get the final answer. Can you please verify the answer you are getting in your booklet? I am multiplying it. What do I get? I'll get a square. A square will be over. So pi square.
So
pi.
हमें 3 and उनसे भी तो निकालना पड़ेगा ना 3 and 7 के लिए.
No, it will. I will find the first. First, I will find the answer for this one. Then I will consider 3. A square gets over. In fact, 4 LCM लेते हैं इधर. I will write it 4 over here. Plus and this 4. So the final answer is coming out to be pi square a square plus 4 divided by 16 a raised to power 4.
Yes sir.
Is the answer correct?
Yes sir.
Now just see. You don't need to calculate it for. The entire calculation is not needed for a equal to 3, 7, 11, etc. Just write down 3 first. When you are writing 3 here, what do you get? Sine 3 pi by 2. That is minus 1. It will make it plus.
Yeah.
But when you write 3 over here, this negative sign will be cancelled by this negative sign. Sine of 3 pi by 2 plus theta is minus cos theta. So this minus and this minus sign
So we get the same.
neglected. So we get the same expression for n is equal to 3, 5 and
7.
so on. I hope you are getting my
Yes, sir.
right? So same for a equal to 3,
7,
7,
11.
11,
Okay.
etc.
Yes sir.
This is the final limit. Have you understood?
Yes sir.
Okay, that's nice. Let us move towards question number 11. I guess we are about to cross 1 hour.
नहीं अभी थोड़ा टाइम तो है शायद.
Had a target of around 1.5 hours. We can finish with 25 problems, but it's not possible, I guess. Let's see. The next problem is belonging to binomial theorem, not the limit.
Okay.
So we will ignore this particular limit. If you wish, I can solve the limit n and the rest of the problems A, B, C, D can be solved. Actually, in this question, for limit x approaching towards 1, 1 minus x square up to 1 minus x to the power 2n divided by 1 minus x up to 1 minus x to the power n. Whole square we are getting. Let this limit be L and he is asking what is the value of L, is the question.
Yes sir.
Rest of the problems A, B, C, D are the problems of binomial theorem, which are very easy problems.
Yes sir.
Let us solve this limit first. You can see like 1 minus x, 1 minus x to the power and one factor gets cancelled at all the places. Right? What is left finally? Can you please tell me?
In the numerator we'll have 1 minus x ki power n plus 1 into 1 minus x to the power of n plus 2 till 1 minus x ki power 2n.
1 minus x to the power n plus 1. 1 minus x to the power n plus 2.
Till 1 minus x ki power 2n.
1 minus x to the power 2n.
Divided
Because all these factors gets cancelled. And what do we get in the denominator?
1 minus x into 1 minus x
1
square
minus x into 1 minus.
x square till 1 minus x raised to n.
Okay. Now divide numerator and denominator both by 1 minus x.
Okay.
What do you get in the numerator? In fact, each factor, see the number of factors here in numerator and denominator are same. So dividing this by 1 minus x, we have a standard limit. 1 minus x to the power n plus 1 upon 1 minus x will give you n plus 1. You have number of methods to solve it. Either this is for x tending towards 1. Either you write x equal to 1 plus h binomial expansion, or you differentiate the numerator. It will be n plus 1 x to the power whatever, and the denominator is minus 1, minus cancel, you get n plus 1.
Yeah.
So you get n plus 1 as the first term. Second term, what do you get?
n plus 2.
N plus 2.
So on till 2n.
What about the last term? 2n divided by denominator. This is 1,
1.
this is 2, and what about the last?
n.
N. What is it? If I multiply and divide it by, this is one factor. This is our final answer, but I want to define it in another way.
Yes, sir.
If I multiply divide it by 1, 2, 3 up to n,
So 2n factorial by n factorial.
yes,
Plus
1, 2, 3 up to n. What do you get here? Factorial 2n divided by
n factorial.
factorial n and factorial n. This is actually 2n here.
Right. Yes, sir.
So this limit is actually coming out to be what?
2n.
2n here. On behalf of this limit, the rest of the problems ABCD can be solved.
Yes, sir.
Okay? So the question number 11 is over. Look at question number 12. Just think about it. How to approach, how to go.
We could think of using the E1 as standard.
No, first of all, the condition in this particular exercise 3 is that you don't have to use series expansion and L'Hopital.
No, not that. I was saying.
Why I am saying this? Why I am saying this? Using that, it's a chance that some questions we solve very fast. But we want to use the theory notes what we have done in class, right? There are some good problems remaining. There, you will stuck. We'll discuss it. Over here in this question, I will write the question first and then we'll discuss limit extending to 1. 1 minus x plus ln x divided by 1 plus cos pi x. Are you not tempted of writing x equal to 1 plus h here? Just think about it. What if I write x equal to 1 plus h? This will be minus h. I will write it minus h. Ln 1 plus h is 5. Divided by, this is something very common factor we are going to get, which we have done many times in class. Cos of pi plus pi h. What is cos of pi plus pi h?
Cos of pi plus pi h is minus cos pi h.
Minus cos pi h. So I will write it 1 minus cos pi h. Don't you think this factor is actually solved if I multiply divided by h square, something like that?
Pi
In fact, pi square h square.
Huh.
So should I do it pi square h square and pi square h square
Yes, sir.
for limit h tending to 0?
Yes, sir.
So this will be over. Now what about this? This is an easy question. We have done number of methods for this particular question. I will write it again. The answer for this one is
Half.
half in denominator. So you'll
it
get
becomes
2.
2.
This is 2.
Minus 2 रहेगा sir.
1 minus
हाँ,
cos
right.
pi h divided by pi
हाँ,
square.
that is 2 only, right?
2 divided by pi square left. And the left part is ln 1 plus h
Minus
divided minus h divided by h square.
Yes, sir.
We have several number of methods for this. Method 1, replace h by minus h and m.
हाँ. Yes, sir. हाँ.
Method 2,
Function.
put ln 1 plus h equal to t. So you get 1 plus h equal to
E की power
e की power t. What do you get finally? H equal to e to the power t minus 1. So this expression, second method, this expression becomes t minus e to the power t minus 1 divided by, am I right?
Yes, sir.
I'm writing h equal to e to the power t minus 1. So this is t, no, this will be plus 1.
Plus.
Okay, so this is final and divided by what? H, value of h. E to the power t minus 1 whole square by t square into t square and multiplied by some answer we have already got, that is 2 by pi square. We will reach to the final answer over here. Now can you tell me, if I write it e to the power t minus 1 minus t divided by t square, because this factor is coming out to be 1, right? And this is 2 by pi square into 2 by pi square. Can you tell me what is this factor?
1 by 3.
No, it's 1 by 2.
1 by 2.
It's 1 by 2. We have done it many times.
हाँ.
Right? So finally it's coming out to be what? If it is coming out to be 1 by 2, then the answer is coming out to be 1 by pi square. I guess we are mistaken somewhere, or you please verify the answer. This is 1 by 2 and 2 by pi square.
Sir, एक minus 1 भी बाहर लेंगे ना?
This minus 1 we are forgetting actually. This minus 1. So this is coming out to be minus 1 by pi square. Please verify the answer.
Yes, sir. Minus 1 by pi square.
It's minus 1 by pi square. See, this method is going long, no doubt about it, but there is some learning actually.
Yes, sir.
You could have done one thing here, you have just differentiated once and you get the answer. In fact, second differentiation you will get the answer. Because here when you differentiate, the derivative is minus 1 and this derivative is 1 by x. When you put x tending to 1, again this numerator becomes 0. So we will definitely get 0 by 0 form in first derivative.
Okay.
So you have to differentiate it twice to get the answer.
Sir, but how did we get Lopathan? Where did it originate?
No, this is logical. And this will study in method of differentiation.
Okay.
So right now you should not hesitate of using L'Hopital. You can use it any question provided you get 0 by 0 or infinity by infinity form. Right? Okay, so this is all over. Question number 12 done.
Yes, sir.
Just think about question number 13, how to approach. There are two limits given simultaneously. It's a good question. No, actually you have to solve y tending to 0 later on, after solving x tending to infinity. Xp means exponential function. X ln 1 plus ay by x minus exponential of x ln 1 plus by upon y and whole divided by y. Actually they make this question dirty by writing this exp. He should not have done this. Instead of this, can I write this x over here if you don't mind? Ln of 1 plus ay by x here, so I can write it here. Okay. Now ln of x to the power m is m ln x. I can write it. Now sure.
Yes, sir.
So do you want me to change this also?
Uh-huh.
This will become what? Just tell me.
The whole raised to x again.
Now do you know e to the power ln k is equal to
Yeah.
k?
Yes.
So this exponential is actually e to the power something.
Hmm.
So e to the power ln of this function will become this function only. Can I write it 1 plus
ay by x
ay by x raised to power x
minus 1
minus 1 plus
by
by
x
this is x actually raised to power x. Am I right?
the whole by y.
And whole by y, I am not interested in y putting over here because I have to solve first limit extending to infinity, and whatever I get, I will solve the limit of y afterwards.
Yes, sir.
Right?
Yes, sir.
So just tell me what kind of indeterminate form you are getting here and here,
So
extending to infinity. Write it here.
that is 0. So 1.
1 to the power infinity.
1 to the power infinity.
1 to the power infinity. Answer is e to the power l here. What will be l?
L will be
Directly you can tell me that answer.
ay. E की power ay.
E raised to power ay. Excellent. Can I write it directly?
Yes, sir.
E raised to power ay minus
e raised to power by.
e raised to power by. And now this y left over here and I can write it. Just don't think that I am using intermediate limit. It's because of one reason, that this function I have to solve for extending to infinity, and whatever I get in terms of y, then I will take the limit y tending to 0. So here limit y tending to 0. Now you have number of methods to solve this
Yes,
question.
sir.
You can do it.
Yes, sir.
Add, subtract 1. You will get e raised to power ay minus 1 minus e raised to power by minus 1 divided by y divided by y. What do you get here? I will multiply and divide it by a
And then
and multiply and divide it by b. What do we get here?
a minus b. That
One.
is 1.
This is again 1, so you are getting a minus. Can you please verify the answer?
Yes, sir. A minus b.
A minus, please, you are getting. This is a very common question you must have done in trigonometry. Question number 14. Think about it, how to proceed. I will write the question on board. You have been given x naught equal to 2 cos theta, where theta equal to pi by 6 is a big hint actually. And you've been given xn is equal to root 2 plus xn minus 1. N is 1, 2, 3 up to so on. And you need to solve limit n approaching towards infinity, 2 raised to power n plus 1 under root 2 minus xx. This is a recurring relation given to you. You have to solve this and the relation is given to you. Can you tell me what is x2? X naught is given to you. In fact, what is x1?
x1 will be 2 plus 2 cos theta.
And what is it?
Cos
2 plus 2 cos theta. 2 is out. 1 plus cos theta is 2 cos square theta by 2.
Okay.
So what is left? 4 cos square theta by 2. What is theta over here?
Pi by 6.
Pi by 6. So it is in the first quadrant. Mod cos theta by 2 will be cos theta by 2.
Yeah.
So this becomes 2 cos
Theta by 2.
theta by 2. x1 is 2 cos theta by 2 raised to power 1.
Yeah.
What is x2?
2 cos theta by 2 की power 2.
Yeah, that's right. 2 cos theta by 2 square. And what about, what do we need? We need
xn.
xn. So what will be xn? Can you tell me? xn?
2 into cos theta by 2.
2 into cos of theta by
2 raised to
2 raised to power n.
yes.
I will put it here and I will solve this limit. I am solving this limit here. Limit n approaching towards infinity I get. And I am writing 2 raised to power n plus 1. In square root I am getting 2 minus 2
Cos theta by 2 raised to
cos theta by
2 raised to n.
2 raised to power n. Right? 2 raised to power n plus 1 under root 2 out, 1 minus cos theta is 2 sin square theta by 2.
Yes.
That is 4 sin square theta by 2 raised to power n plus 1,
Yes,
isn't it?
Yes, sir.
Again I'll take the mod, the positive sign will come out and this will become 2 times 2 raised to power n plus 1 into sine of theta by 2 raised to power n plus 1. What exactly you want to solve? You have to solve this for limit n tending to infinity. I guess you got the answer.
Yes, sir.
What to do? I will divide it by theta by 2
Theta.
raised to power n plus 1, multiplied by theta by 2 raised to power n plus 1.
Standard limit equal
This
to
is a standard limit for n approaching towards infinity. This is approaching towards 0. 0. What do you get exactly? 1. This is over from this place.
2 theta.
I guess we have committed mistake in some particular step in calculation. Here the answer is coming out to be 2 theta and theta is pi by 6. So your answer should be coming out to be what? Pi by 3. Just verify the answer
Yes, sir.
whether it is right or wrong.
So, pi by 3.
Pi by 3 is correct. Calculation is wrong. Basically catch was you have to manipulate it trigonometry.
Cos theta को मतलब
Continuously लिखते चले जाना.
हाँ.
Right? Got it? Alright. So we have reached more than half now on 15th. Not more than half. 3/4 at least. Question number 15. I need the approach from you for question number 15. Limit x tending to 0. 1 plus x ln 1 plus x divided by x square minus 1 by x. What indeterminate form it is first of all? We have to
Infinity
look at.
minus infinity. Infinity minus infinity.
Infinity minus infinity. Very good. Just look at the factor and denominator. Just take LCM, x square LCM. What do you get here? 1 plus x ln 1 plus x minus x.
हाँ minus.
See, on solving 1 or 2 steps, you will find that this question is repeating with the previous one. I will multiply it by 1 and I'll get ln 1 plus x minus x. Now I'm multiplying it by this, I'll put it in the bracket because I know that ln 1 plus x minus x divided by x square is something what we have done,
Yes, sir.
right? And what else is left? X ln plus x ln 1 plus x whole divided by x square divided by x square. I guess the question done.
Yes, sir. Standard limits.
Standard limit. This we have already done. This x is over.
Yeah.
ln 1 plus x by x we have done. Do you want me to write the final answer? Okay. Question number 15 over. Question number 16. It's a nice question. Read it. A circular arc of radius 1, circular arc of radius 1, this is your arc, its radius is given to you 1, subtends an angle x radians where x between 0 and pi by 2, this is given to you x, shown in figure I am making here. And is given that we are drawing tangents here and these tangents are meeting at a point C. Is given these points A and B. Let T of x is the area of triangle ABC. Area of triangle ABC. I will join this. Area of triangle ABC, right? And S of x is area of the shaded region. This is your shaded region, right? And he is asking what is T of x, what is S of x, and third question is asking what is T of x upon S of x for limit extending to 0. Actually, we are interested in this. If we get this, we have to solve this only. So let us find T of x, S of x and all. You must be knowing the property that if you are trying, see if you make the complete circle, okay, and if you draw the tangents over here,
Yeah.
then point OACB, it's a cyclic quadrilateral.
Quadrilateral. Yes.
If this angle is x, then this angle would be
2a.
pi minus x,
Huh.
opposite angle of
Yes.
cyclic quadrilateral. So to find the area of the triangle, let this length be L. And this angle I know. So area of the triangle ABC I will write here, that is half L square sine of pi minus x. In fact, I will write this area here. Area of triangle ABC equal to half L square sine pi minus x, which is actually sine square sine x. But I don't know the value of L. That you should know. I have assumed L.
Huh.
Okay? And you can understand, for extending to 0, L will also change. So what is L we have to find here? If I join this line, what angle is this?
X by 2.
X by 2. Very good. This is x by 2. This is x by 2. Can you tell me what is this angle? See, this is radius and this is tangent. So what is this angle?
90.
90 degrees. This angle is 90. This is x by 2. This is your perpendicular and this is your base.
Right.
So what is L?
L by x is equal to
L by 1. L by 1.
L is equal to tan of x by 2.
Very good. L is equal to tan of x by 2. Can I write the value of L there?
Yeah.
So this is coming out to be half tan square x by 2 into sin x.
Yes, sir.
I have written the value of L is equal to tan x by 2.
Yes, sir.
Okay. Now move towards the next. We have got the area of triangle ABC. Area of sector, this shaded region. How to find the area of this shaded region? Can you please tell me? I know the area of triangle ABC. In fact, can we find the area of this sector OAB? What is it?
Sir, yeah.
R square theta by 2.
Okay.
R square theta by 2.
Yes.
R square is 1. Theta means this x by 2. So the area of sector is coming out to be what?
X by 2.
Shaded region area S of x I am writing. S of x is equal to x by 2. Right? Minus area of this triangle. Can you find the area of this triangle?
Sir, it will be a isosceles triangle, so 1, 1 and...
You know this angle,
Huh.
right? And you know these two sides. How will you find the area?
So,
How did you find the area of this triangle? L square sine pi minus x. And what will be the area of this triangle? OAB. 1 and 1, and then the angle x. What do you get? Half 1 into 1 into sine x.
Okay.
Half 1 into 1 into sine x. I guess you got the point.
Yes, sir.
Okay. So finally, what are you going to get? S of x we know this. To finalize the answer or to verifying the answer, we have to solve this.
Yes, sir.
Now t of x I have, this is t of x I have written there, half tan square x by 2 into, I will write it 2 sin x by 2 cos x by 2.
Yes, sir.
It's just because of one reason that I want to cancel this, right? And this 2 is over now. This is divided by
X minus sin x.
x minus sin x
The whole by 2.
whole by 2. So I can write 2 over here,
Yes, sir.
right? I will write it sin square x by 2 upon cos square x by 2.
Yes, sir.
This is in the multiplication, no? Sin square x by 2 upon cos square x by 2. See, in fact, we don't need to cancel something. This sin x was fine for us. I mean, what do I need here? Here I need x cube.
Yeah.
Can you tell me why?
Standard result 1 by 6.
Yeah, 1 by 6. X minus sin x by x cube we have done. That's 1 by 6. So x cube I will multiply here.
Yes, sir.
Right? And I need x square by 4 for this tan square x by 2.
X square, okay.
And I will rub this, if I rub this, then it will be a problem. We will do it the same way.
Okay.
So x cube is needed here. So I will split this x cube as x square and x.
Yeah.
This x square needed 4.
tan square x by 2.
So tan square x by 2 upon x by 2 will become 1.
Huh.
And 4 multiplication is also needed.
Huh.
You have to write 4 here.
Yes, sir.
So this bracket is over. Okay. Now sin x by 2 by 2 into 2 is needed.
Yes, sir.
So this becomes 1.
Yeah.
Right. So what is left finally? Can you please tell me?
Finally.
This is over.
Huh.
This is 1. 4 to 8 leave over here.
That
And
comes
numerator 2 is left. So I will write the first,
And
I will write the numerator.
1 by 6 also.
2 divided by, this I will write 1 by 6 here.
Into 8.
Into 8. Yes, you are right.
And that's all.
That's all. This should be the final answer.
Yes.
Let us calculate it. This 6 will go here, 12 by 8.
3 by 2 will be.
So this is coming out to be 3 by 2. Just verify the answer.
No, sir, the answer is wrong. It is 1 by 2.
It's 1 by 2. Just look at the mistake if you have committed anywhere. X minus sin x
So
is
1 by 6 ही होता है x minus sin x.
x minus sin x divided by x cube is 1 by 6. That is correct. Look at s of x and t of x if we have done any mistake. I think our powers are balanced, so that there is no issue of powers.
हाँ.
Only the numerical values are wrong somewhere, if possible. So you can conclude it. Again try.
हाँ.
Otherwise our answer seems to be correct.
ऐसा mistake तो वैसे कुछ दिख नहीं.
T of x by s of x. There can be a calculation error which you solve once and identify it.
Method is right.
Method is there. Method you must have understood.
Yes,
Right? Is it okay?
Yeah.
Right. Look, question number 21st, 22nd we have already done.
Classmates.
It's a classroom example, right? And we are on question number 70.
Sir, 21. Have we done it in the classmates?
No, 22 we have done.
22.
We have very good questions, question number 24. And this is a telescopic series. Try and identify this telescopic series. Question number 17 and 18. 17, I'll give you a hint. Not solving the full problem. Just write down the formula for sin 3x. That is coming out to be 3 sin x minus 4 sin cube x. Right?
Yes, sir.
Then value of sin cube x will become, I'll put it to this side, 3 sin x minus sin 3x divided by 4.
Yes, sir.
Just instead of sin cube x by 3 raised to power n, sin cube x by 3 raised to power n, substitute 3 sin x by 3 to the power n minus sin x by 3 to the power n minus 1. You can see it clearly that this is becoming telescopic. If this is TR, are we missing 3? No, we are not.
Okay.
This is 3 sin divided by 4 we are missing. You just look at this. If I write it Tn, but this 3 is coming out to be extra.
हाँ वही तो telescoping नहीं करता कहीं miss क्या होगा I guess
No, we are not missing anything. Let's see. Like that. You have something on outside also, which you have to multiply, because you don't need sin cube x to the power 3n only. You need something else also in the question. This is question number
17.
17. So it's 3 to the power n minus 1 also there. 3 to the power n minus 1 into 3 to the power n minus 1. Just look at this now. Multiply this with 3 to the power n minus 1. What do you get? 3 to the power n sin of x by 3 to the power n
Yes.
minus 3 to the power n minus 1 sine of x by 3 to the power n minus 1. I guess
now it's telescoping.
telescopic. You'll get a standard function and a very good limit in the end. You can solve it easily, for sure.
Okay.
Are you clear?
Yes, sir.
Okay. Question number 17 done. Question number 18 is also a telescopic. Think about it. Just write down the formula for tan 2 theta and see it becomes telescopic. 1 minus tan square theta is equal to tan 2 theta by tan theta, I guess. Just check it once.
We want tan square theta, right?
Yeah.
So,
We are left with only 6 problems, 7 problems. I'm wondering that I'm able to solve all 25 problems with you.
Sir, it will be what? It will be tan of 2 theta minus 2 tan theta.
Tan of 2 theta.
No, I'm saying something wrong. Wait. 2 tan theta upon tan of 2 theta.
2 tan theta upon
Tan of 2 theta.
tan of 2 theta.
This is in minus. 1 minus this quantity.
No, I will write it. See, you have tan 2 theta is equal to 1 minus tan, this is 2 tan theta upon 1 minus tan square theta. So 1 minus tan square theta will become 2 tan theta by tan 2 theta. Right? I'll carry it over here. Now what exactly he is asking? He is asking 1 minus tan square theta by 2 raised to power r. And this is in the product. R equal to 1 to n, and function is defined as f of n theta. Let us solve it. What is the issue? If I replace theta by 2 raised to power r, I have to replace it over here also. Okay? So let us write this. Y upon, product of r equal to 1 to n. This becomes, what should I write? Can you please tell me? Suggest to me.
Sir, 2 tan theta by 2 raised to r
divided by
tan theta by 2 raised to r plus 1, r minus 1.
theta by 2 raised to power
r minus 1. Yes, sir.
Okay, let us expand it. Okay, so you will write this to how many times? N times?
N times.
This will become 2 raised to power n. What is left inside? I write the first term r equal to 1 के लिए. Tan theta by tan r equal to 1 I am writing now.
Sir, tan theta by 2 upon tan of theta हो जाएगा ना?
Tan of theta by 2 divided by
Tan theta.
tan theta.
Yeah.
What is the second term?
Tan of theta upon tan of 3 theta by
I am
2.
writing r equal to 2 now. Don't forget this. So this will be tan of theta by 2 square. I am writing r equal to 2 here. Divided by denominator tan
Tan of theta by
theta by 2.
2.
Right? Now look at the cancellation. This cancellation goes like this. Goes like this. So what will be left? The last term of this side.
Tan of theta by 2 raised to n.
Tan of theta by 2 raised to power n divided by cancellation.
Divided by tan theta. Finally it will be.
It will be cancelled. Right? So what is left finally? Can you please tell me?
Tan
2
of
raised to power
theta
n.
by 2 raised to n
Tan theta by 2 raised to power n
upon tan theta.
upon tan theta.
Yeah.
And the limit is n is approaching towards infinity. I guess the question done. For n approaching towards infinity, this is approaching towards 0.
0.
Isn't it?
Standard limit we can apply.
Standard limit. So I will divide it by
multiply
theta by
by
2
theta.
raised to power n. Multiplying by theta by 2 raised to power n. What do you get? Finally this gets cancelled.
This is 1.
Right?
And then that
This is
becomes
1. And what is left? 2 raised to power n cancel with this. What is left? Theta by tan theta.
Theta by tan theta.
Don't forget, this is not 1.
Yes, sir.
Theta tending to 0 is not given. He is asking what is f of n theta, which is theta by tan theta.
Yes, sir.
What is the final answer he wants to ask us? He is asking limit n tending to infinity f of n theta. This is what he is asking. What is the final result? So it should be theta by tan theta.
Yes, sir.
Is it okay?
Yes, sir.
Right. So next problem is a disaster. I mean, it seems to be something like you have never seen such problem and you would never like to solve such problems. But the problem is not that difficult. Just look at this. You have under root cos 2x plus 1 plus 3x to the power 1 by 3.
By
See, the challenge over here is not to use binomial theorem or
minus cube root of
minus cube root, so I'll write 1 by 3 power 4 cos cube x
minus ln of 1 plus x the whole raised to 4
minus ln of,
1 plus
so I can write it 4 of ln 1 plus x, no?
yes.
Because you are solving it for x tending to 0, so it will remain positive anyways. 0 plus it should be given. But anyways, this is coming out to be this divided by what? 4 once again. Oh, 4 will be
The whole
cancelled.
raised to 1 by 3.
This 4 is cancelled throughout. It's useless. Right? Whole divided by what? X. Whole divided by x. Right?
Yes, sir.
Now, can you tell me an approach over here? How will you approach?
So we cannot use binomial now.
No. See, on all the other problems you can use it. In this exercise, we should try.
Okay, yes, sir.
Rationalization over here, just think about one thing. X tending to 0 over here.
Huh.
First of all, we must realize what kind of
0 by
indeterminate
0
form
form.
it is. 0 by 0 form.
Huh.
Then, is this becoming 0?
It's becoming 1.
1. So, if I subtract 1, see, look at this. If I write it like this, cos 2x plus 1 plus 3x to the power 1 by 3 by 2 minus 1 by x.
Okay.
Then again this becomes 0 by 0 form.
Huh.
And it is helpful also. Because in this case I can rationalize it.
Huh. Okay.
Rationalization factor is there. This becomes 1, this is 1. So I can rationalize it.
Yes.
Here I can't rationalize because of one reason. Here the power is 1 by 2, here the power is 1 by 3. I can write it 1 raised to power half and I can rationalize it.
Yes.
And same way, if I am subtracting 1 here, I have to add 1 here.
Huh.
Cos cube x minus ln of 1 plus x to the power 1 by 3 minus 1 divided by what? X.
Divided by x.
Now the question is reduced to 2 questions. Which again seems to be difficult but not that difficult actually. When you will rationalize it, look at the rationalizing factor in the denominator which will be root 2 I guess. Because this is 1 and this is 1 and you are adding in the denominator. So this will be root 2 anyways. And again if you rationalize it, you take it A, the complete part I am taking out A, this complete part A and this complete part B.
Sir,
Yeah,
इससे कुछ help होगा क्या? If first step में you would have replaced x by minus x, so जो 1 by 3 वाला term है वो शायद से cancel होता
No. Square root में you can't add it, no?
नहीं, square root वाले में नहीं. But जो 1 by 3 वाला term है raised to 1 by 3.
This, how will you add it inside?
नहीं, right वाला term जो cos cube x.
This one?
हाँ.
Okay, x minus x से replace किया ln 1 minus x, how will you add it? Power 1 by 3 and then adding with power 1 by 3. This will remain same. This will remain same.
हाँ.
And
अच्छा हाँ.
this will be different.
बनेगा भी नहीं right.
yes. Are you clear?
Yes sir.
Okay. So rationalizing this. What is the factor in the numerator after rationalization? Cos 2x
Cos 2x
plus
1 plus 3x
1 plus 3x to the power 1 by 3
divided by 2.
divided by 2. Can I write it minus 2 over here?
Yes.
And whole divided by
Whole divided by 2.
Can I write it
2s.
root 2 also?
हाँ root 2 fine.
Because the rationalization factor here and
Yeah.
x over here. Right?
Yes sir.
And what else do I have to write here? I am multiplying it by a square plus ab plus b square divided by 3.
Yes sir. So it becomes a minus b.
Can you
A
tell
cube
me why did I write this 3?
So because
Because a is 1 and b is also 1. If I write it over here, this will be 3. Because this will not be making indeterminate form. Not at all related with indeterminate form. And what is the numerator left? Can you please
a
tell
cube
me?
minus b cube which will be
Which
cos
will be
cube x
Cos cube x
minus ln of 1 plus x
minus ln of 1 plus x to the
minus
power 1 by 3 minus 1. Whole divided by 1?
1 by 3 लिखने की जरूरत है ना क्योंकि वो तो a cube
No. 1 by 3 नहीं आया. Sorry.
minus 1
Divided by what?
3x.
3x. 3x. Look at the question now and look at the question here. Just look at this factor first.
Yes, sir.
When I take it 1 plus 1, cos 2x minus 1, it's x, no? Cos 2x minus 1 divided by x will be 0.
Divided by x will be 0.
If it is x square, then it is half.
Yeah.
Got it?
Divided by x will be 0.
Cos 2x minus 1 divided by x will be 0.
0. Yes.
I will write it. What is the harm in writing one step? Cos 2x minus 1 divided by 2 root 2x. And what else is left? Plus 1 plus 3x to the power 1 by 3 minus 1 divided by 2 root 2x.
Yeah.
This will give you something. But this will give you
0.
0. Are you clear with this 0?
Yes, sir.
If it is x square,
Then we get.
then we get 1 by 2 for this. Not 1 by 2 exactly.
But some value.
But some value. Now what about this? This you can solve easily. Now again you have to use binomial theorem. 1 plus 3x to the power 1 by, but you have used binomial theorem appropriately here. So 1 plus nx में 1 gets cancelled. When I write nx, then 1 by 3 times 3x, 3 gets cancelled, only x left. Throughout x common cancel, what is left? 1 by 2 root 2 left.
Yes, sir.
Can I write it directly 1 by 2 root 2?
Yes, sir.
1 by 2 root 2. Okay. Now what about this? This is again easy. Take this factor with this one. Don't forget this negative sign here. Huh?
Yes, sir.
Minus of cos cube x minus 1. What will you write for this? Factors.
Cos x plus 1.
Cos x minus 1. Cos x minus 1
Into cos square x.
into
plus
cos square x
plus
plus
1
1
plus
plus cos x divided by 3x.
3x.
And
Minus
this
ln.
minus, since this minus sign is here, it will make this part plus. Plus
ln 1 plus x.
ln 1 plus x divided by what?
3x.
3x. Okay. Now again, see, this is very interesting step. This will become 0.
Okay, yes.
Right? So what is left? ln 1 plus x divided by x is 1.
1 by 3.
1 by 3. And that too positive 1 by 3.
Yeah.
Because we have already considered this negative sign.
Yes.
By this one. So 1 by 3 is over here.
And
And 1 by 2 root 2 over here. The answer is very dirty. We have to be a little in fear that whether the answer is right or wrong. But let us write the final answer and check
3
it.
root 2 plus 1 by 6.
No, 1 by 2 root 2.
The final answer I was saying.
1 by 2 root 2 plus 1 by 3. Can you please check the answer? If it is wrong, you have to calculate it at home.
Question number कौन सा था? 18 नहीं 19. It is 19.
Answer is what?
19.
How come 19?
Misprint होगा because 19 का ये 90 कहता है.
No, misprint. Oh, we are definitely mistaking somewhere because he is asking it to be L is equal to A by B.
अरे okay हाँ.
Then we are mistaking somewhere. Let us check.
सर तो अपना value ही फिर नहीं right आया ना.
हाँ, value ही हमारा wrong है. Let us check. Rationalizing factor over here when we are this is 1 no 0 के लिए
हाँ.
हाँ this complete part is 1 plus 1 so this will become 2.
Yeah.
Why this root 2 we have written here?
Because वो उसका जो नीचे factor आएगा वो root of नहीं अपन हाँ वो root 2 नहीं आएगा वो only 2 आएगा ना.
हाँ.
root 2 नहीं आएगा वो. Right.
This will be only 2.
Only 2.
This we are mistaking actually. Got it? Because root 2 and root 2 will be there.
हाँ.
It will become 2. So here we are getting
root 2 नहीं ना मतलब वो 1 plus 1 हो जाएगा.
1 plus 1 हो जाएगा.
हाँ.
Root 2 नहीं होगा. That's right. This is 2. And so this is over.
Extra 2 एक और लिखना रहेगा ना.
हाँ.
Extra 2 मतलब into 2 कर देंगे ना.
Why?
सर क्योंकि 2 तो पहले से था ही वहाँ पे and then नहीं क्या?
ये तो 1 ही आएगा ना. इसका result this is over. This root 2 is not here, not here, not here.
हाँ okay.
Not here.
root 2
Anyway, we are writing extra root 2 bus. That's it.
Yes.
That means in last step we are writing extra root 2. So this is 1 by 2 plus 1 by 3. What is it? 5 by 6.
But that is again not the answer.
So there's a mistake. Let's see what is that. We have to check this mistake.
सर वो उधर ही मेरे ख्याल से 1/4 होगा. एक सेकंड देख रहा हूँ आपको.
When we are rationalizing this,
हाँ
so rationalization in numerator is fine.
हाँ
Rationalizing in
हाँ सर
denominator,
1/4 हो जाएगा सर.
rationalizing the denominator, we are having only x over here. Nothing else, no? Other than this.
Yes sir.
Now if I divide it denominator, then this becomes what?
सर 1/4 बना सर देखिए because numerator में it will become that quantity and then अपन ने LCM लिया था. So वो cos of 2x plus 1 plus 3x is to 1/3 minus 2 divided by 2x into the rationalizing factor.
Okay, numerator में 2 कहीं cancel किया है क्या हम लोगों ने?
अपन ने ये लिया था ना, ये common LCM लिया था 2 का.
अच्छा LCM लिया था यहाँ 2. Oh, तो this becomes 4.
This becomes 4.
Okay. 12 will be here and 4 plus 3.
7 by 12.
7.
7 by 12.
7 by 12.
19. Right.
That's right. See the careless mistake. This will be 1 by 4. 1 by 4. I mean, carefully solve it. You get this 1 by 4. And what do we get here?
7 by 12.
7 by 12. That's nice. It's a very dirty question. Dirty calculation. Actually, we didn't care the reason we missed it. Now the questions are easy. One question is good conceptual question. Otherwise the questions, remaining 5 questions are very easy. We have reached 21st, no? 20th.
20th.
One question we are going to leave, that is question number 22. This is cos hyperbolic pi by x upon cos of pi by x raised to power x square, and the limit is x is approaching towards infinity. In advance it is given that cos of hyperbolic x is actually equal to, in fact t is actually equal to e to the power t plus e to the power minus t divided by 2. So I will write pi by x is equal to t.
Okay.
If I write pi by x is t and x approaching towards infinity means t approaching towards 0.
0.
So this is t is approaching towards 0. What exactly are we going to get here? Cos of hyperbolic t divided by cos t raised to power pi square by t square.
Yeah.
I will write this value also, e to the power t plus e to the power minus t
by 2
by 2
cos t
raised to power
pi square by t
pi square by t square. And t is approaching towards
0.
0. Right? Now look at the indeterminate form. What is indeterminate? What indeterminate form do we get here?
So दिखने से तो मतलब ऐसे लग रहा है कि 1 by 1
No, you just write now e to the power 0, e to the power 0 is 1 plus
1
1.
raised to infinity.
1 raised to power infinity. So what is the final answer for this? E to the power n. And what is n? E to the power t plus e to the power minus t divided by 2 cos t
minus 1
into
pi square by t square.
pi square by
T
t square.
Yes.
I will take this 2 cos t here and I will write the step L is equal to e to the power t plus e to the power minus t minus 2 cos t divided by t square into pi square
by 2 cos t.
by 2 cos t. Actually this 2 cos t is useless for us.
It becomes 1.
It becomes 1 in the end. Are you not tempted of adding and subtracting 2 over here?
Yes sir.
Because that will
Start
be
with
balanced with the t
1
square.
by 2.
Right? So let's see, e to the power t plus e to the power minus t minus 2. In fact, plus 2. No. Minus 2 is
Minus
needed
2.
here. Minus 2. Because I need plus 2 for this. 1 minus cos t. Divided by t square and divided by t square. And as the question done.
Yes sir.
Pi square by 2 cos t. Just put the limit L. What is this? see, carry out e to the power minus t common. What do you get?
So e to the
E
power
raised to
2
power 2t
minus 2.
minus 2 e to the power t
हाँ.
plus 1 divided by t square is 1.
Yes.
In fact, 1 square you can say. E to the power t minus 1 whole square by t.
Yes, sir.
Right? So this becomes 1. E to the power 0 is also 1. Right? This is 1 plus
1.
What do we get here? 2
Plus
into
pi
1 by
square by 2. अच्छा 1 by 2.
2 into 1 by 2. The
Pi
whole
square by
bracket. The whole bracket. What is left here? Pi square
by
by
2.
2. So this is over. 1 plus 1, 2. Cancel.
Answer is
2 and 2
pi
cancel. The pi square is the answer.
Yes, sir.
It's just very fine.
हाँ, yes sir. E to the power pi square.
E to the answer is not pi square. You must be careful of writing the answer. It's not pi square. The answer is e to the power pi square.
वरना वैसे भी ऑप्शन में तो रहेगा ही.
No. Sometimes you'll write pi square as the answer, and none of these will be there. So the student will commit mistake.
So but advance में none of these नहीं रहता.
नहीं रहता है. That's true. But mains में रहता
हाँ,
है. You should be careful.
Yes sir.
That's right. So we've reached question number 21. Again, this is a question of geometry, and you can solve it. Try.
Yes.
What he's asking. Try. Take 2 minutes to make the figure at least. Because thereafter we are left with only 2 problems. 25th is inverse trigonometric functions, an easy problem.
Yes.
मुझे देख के आप बता सकते हैं ये लेक्चर का ड्यूरेशन? नहीं पता.
अराउंड 2 घंटे होने को आ गए होंगे.
है ना?
Because we started off at somewhere around 450 or something like that. 440, 450.
Let's see. अभी 2 मिनट में पता लगेगा. See, you've been given through a point A on circle. Let us this point in the bottom. A chord AP is drawn, right? This is a tangent. This is AP.
Yes, sir.
Writing like this, saying this meets in D. ये थोड़ा distance पे बनाना because this distance is this distance same. This is, he's saying, draw a tangent, draw a chord AP, and draw a line. Just I'll read the question, the full question. Through a point A on the circle, a chord AP is drawn. I have drawn it. On the tangent A, a point T is being taken such that AT is equal to AP. AT is equal to AP. That means I should take T somewhere here. So that figure will be appropriate.
Yes, sir.
Right?
Yes, sir.
This is point T. And he's asking, he's given that these two are same. Okay? Now what is he saying? If TP produced meet the diameter through A at Q, this point is given to you Q.
Yes.
Prove that the limiting value of AQ, limiting value of AQ, when limiting value of AQ, when P moves up to A, when P moves up to A, then T also moves up to
That
A.
is AP tending to 0.
Yeah, AP tending to 0, you can say. AP tending to 0 or AT tending to 0, right? Double the diameter of the circle. That means when AQ, when he's asking the question, I will write it properly. When P approaching towards A, AP approaching towards 0, AT is also approaching towards 0. He's
AQ
asking
approaching
what is AQ approaching towards.
No, he's asked us to prove no, that AQ approaches towards.
He's asking to prove us. What is AQ? AQ approaching
double
towards
of diameter.
4R. If R is the radius.
Yeah.
Let it be center O. and give this point also. We have taken PQ, so this is D. Any point we can take. Okay, let us consider this angle as theta. Now can you please tell me, when P is approaching towards A, theta is approaching towards what? 0 or 90?
0.
No. Just think. When T will come to this side, angle will increase or decrease?
It will increase.
It will increase.
Yeah,
Right? And very near you take. You will go like this.
Yeah. So it tends towards pi by 2.
So here, if I take this angle as theta, then theta approaching towards pi by 2, you have to prove that AQ approaching towards 4R.
Yes, sir.
Okay? So I have to find out AQ in terms of theta, and for theta tending to pi by 2, I have to solve it. So let us draw all thetas possible in this diagram. This is theta and these two are same. If this is theta in front of this, then this is also theta.
Theta. Yes, sir.
Then this angle would be
180 minus theta.
pi minus
Pi
theta.
minus theta.
What about this angle? Can you tell me? This angle?
Pi by 2 minus theta.
This is theta, this is theta. So pi
Pi
minus 2
minus
theta.
theta. Pi minus 2 theta. Yes.
And this total angle is, can you tell me this total angle?
Pi by 2.
Pi by 2. So what would be this angle? In this triangle, actually I am looking at triangle APQ. What is this angle? Angle
2 theta minus pi by
PAQ. Angle PAQ. What is it?
2 theta minus pi by 2.
It is actually pi by 2 minus pi minus 2 theta. Isn't it?
Yes, sir.
Pi minus pi by 2 is minus pi by 2
Hmm.
plus 2 theta. So this is 2 theta minus pi by 2. Right? And what about this angle? This also we can find.
Yes, sir. Pi minus theta.
Pi minus 2 theta minus pi by 2 minus
Pi minus theta.
pi minus theta. Very good. What is left finally? Just tell me. This pi and this pi will become 2 pi? No.
Cancel.
Cancel.
Yeah.
Cancel. Over. This pi by 2 left.
We'll have minus theta and we'll have
Pi minus theta.
pi by 2 minus theta.
Yeah, I'm sorry. This is pi by 2 minus theta. Pi by 2 minus theta.
Yes, sir.
So we have completed a triangle. Do you know why we have completed the triangle? We want AQ
In terms of
and
theta.
in terms of AP.
Huh.
Right? So AQ upon, you know sine rule? AQ upon sine of pi minus theta. Sine of pi minus theta is equal to AP upon sine of pi by 2 minus theta. See, this is the rule. This is ABC. Small a, small b, small c. Sine A by A is equal to sine B by B, etc.
Huh.
Well, third more result I want to write here. So you are finding AQ in terms of AB. Sine pi minus theta is what?
Sine pi minus theta is equal
Sine
to
theta.
Sine theta.
So what is left? AQ is equal to AP
Sine theta.
sine theta by cos theta.
Tan
Now I just have to write AP in terms of theta and my work is over. Can you find AP in terms of theta? Just join this. See? And look at this right angle triangle. This is diameter and this is right angle.
Huh.
And this is your radius.
Yeah.
In fact, diameter.
Diameter.
So, is there any angle you know in terms of theta to calculate this? Yes, we know this angle. 2 theta minus pi by 2.
Yeah.
So, this is 2 theta minus pi by 2 and you have to find out this one. And AP you have to find out.
Huh.
So, what is AP upon 2R? AP upon 2R.
It will be equal to.
See, this angle is theta. This is AP and this is 2R.
Cos of pi minus theta.
Cos of 2 theta minus pi by 2.
Sir, cos of.
What is cos of 2 theta minus pi by 2? Just tell me. This is perpendicular, this is base. Right? So this is cos of 2 theta minus pi by 2, which is actually cos of pi by 2 minus theta.
We can.
And which is sine 2 theta. Right?
Yes, sir.
So what is AP? AP is equal to
2r into sine 2 theta.
2r into sine 2 theta. Right? I will write this AP here and I will get AQ in terms of theta.
Yes.
What do you get? AQ is equal to
2r sine 2 theta into tan theta.
2r sine 2 theta
Tan theta.
into tan theta. In fact, I want to write it in terms of sine theta and cos theta.
Sine theta by cos.
I'll tell you why.
Yes, sir.
I will write it 2 sine theta cos
Cos
theta.
theta. Okay. cos theta cos theta.
Then cos theta gets cancelled. What do we get finally? Just tell me.
2r
4
sin square theta. 4r
hours,
sin square
4 hour
theta. Sin square theta.
sin square theta.
Yes, sir.
Now as theta approaching towards pi by 2, AQ approaching towards 4r.
Hence proof.
Very easy. Got it? It's a good question, I guess.
Must, sir.
I know? Right. It took time, but it's a good question. Finally, we are left with two good problems and one very easy problem. We are not going to solve 22nd as we have solved it in class. X replaced by minus x and add over. And the next problem is a very good problem. One of our faculty has given very good solution for this. I will write the same solution. 1 minus cos x into cos 2x cos 3x cos nx divided by x square. In fact, I'm thinking of giving this problem in the next lecture for cash price. If you really think of solving it home, I wish that you should solve it at home.
Yes, sir.
In next lecture only I will give this problem without series expansion
Okay.
and without L'Hopital. How will you solve it?
Yes, sir.
Okay, let's see. So I will leave this problem right now and I will solve it during the regular lecture on Tuesday. So just read the second last problem for the day. Question number 24. It's been given A1 greater than A2. It's very important relation given to you. You should notice it carefully.
Yes, sir.
P1 greater than P2. Pn all are positive. And for An it is greater than 1. One more relation given to you, P1 plus P2 up to Pn is equal to 1. And he is asking if f of x is equal to P1 A1 raised to power x plus P2 A2 raised to power x up to Pn An raised to power x, right? Raised to 1 by x. Then his first question is limit extending to 0 minus.
0 plus.
Is it plus?
Yes, sir.
Yes, I'm sorry. Fx. Second question, limit extending to infinity. This is very cheap question, second one. And in fact, third one also. Limit extending to minus infinity, Fx. First question, no doubt, dicey and good. We will in fact look at the second and third first. Just look at the sense the question. For x tending to infinity, what's happening here? For x tending towards infinity, a1 raised to power infinity, everything is greater than 1. Means this is infinity, this is infinity, this is infinity, everything is infinity. But what is the largest infinity here? Can you tell me?
Sir, it will be.
What is the greatest term? A1. Out of all, A1 is the largest.
That way.
Raised to power infinity. So largest infinity, if I take common, means A1 raised to power x common, then what is left inside? A1 is out, only A1 is out. I am solving this question here. Limit extending to infinity, A1 is out. What is left inside? P1?
P1 by A1.
P1
Sorry.
P1.
Right. Sorry.
plus
Plus P2.
P2,
A2 by A1 raised to power x.
A2 by A1 raised to power x. Don't you think this is coming out to be 0?
This is coming out to be 0. Right. Because
Because
it
A2 is less than 1.
Huh.
Just think about the next term.
All of them.
All of
the
them
following
will
terms.
become 0.
Huh.
0. Right? Raised to power 1 by x, which is also 0.
Which is also 0. Yes, sir.
And here P1 left. P1 raised to power 0 and P1 is not 0. It is given that P1 is greater than 0. So some positive number raised to power 0 is 0.
1.
1, sorry.
Huh.
So what is the final answer for this?
A1.
E1.
Yes, sir.
Similarly, think about the next one. What do you get?
So उसमें
Extending to minus infinity is opposite actually.
उल्टा हो जाएगा. एक
What will be the answer? Directly write down the answer.
AN.
AN will be the answer. Excellent. Right?
Yes, Yes, sir.
Now look at this, extending to 0 plus. For extending to 0 plus, this becomes a1 raised to power 0 is 1.
Tending towards 1.
p1 plus p2 plus p3 up to pn left, which is 1.
Which is
1 raised to power infinity.
Hmm.
In first question, the indeterminate form is 1 to the power infinity, so the answer is e to the power n, where l is equal to p1 a1 raised to power x plus up to pn an raised to power x
minus 1.
divided by minus 1 divided by x. Am I right?
Yes, sir.
This is what we are getting here.
Huh.
And we have to solve it for limit extending
Extending to 0 plus.
0 plus. Have a good look on the question. We have done this question today. There was a question a1 raised to power 1 by x, a2 raised to power 1 by x, and we had n over here.
N over here.
What if I can have n over here?
Plus minus.
No. Just see, you have been given 1 is equal to this. If I write 1 is equal to
अरे हाँ ठीक है, हो गया.
1 is equal to p1
Common
plus
check.
p2 up to pn, what happens?
Then P1 comes out.
Then
common.
p1 comes out to common from this place, and what do I get?
A1 is to x.
a1
minus
raised to
1
power x minus 1 divided by x,
which-
etc.
Yeah.
What do we get in the first term? Can you please tell me?
P1
p1
ln A1
ln a1
till
etc.
Pn ln A1
So ln a1 raised to power
Pn
P1.
P1 हाँ.
plus ln a2 raised to power p2 plus up to so on. Right?
This is an exponential.
This is ln a1 raised to power p1, a2 raised to power p2, an raised to power pn.
Pn.
And our answer is e to the power n. So what is the answer?
A1 is to P1, A2 is
a1 raised to power p1. Can you please verify the answer of all these three?
to... Yes, sir. Yes, sir. We are doing. अच्छा नहीं 24 we are doing.
We are doing the last question, I guess.
A1 AN हाँ sir right answer.
Right now?
Right.
Okay,
Yes, sir.
done. As far as this 25th question is concerned, it's not a question of limit actually, it's a question of inverse trigonometric function.
Yes, sir.
We can avoid it right now,
Okay.
right? We can avoid it right now. So, last exercise, as an example, wait Sachin, last exercise is not meant for solving at home, it is the kind of examples we are taking in class,
Yes, sir.
right, which you can view on your video.
Yes, sir.
It will be uploaded by tomorrow morning, I guess. Okay? Fine, thank you.